Here we go again, learning a C++ from scratch, day 13. So today we are going to read a OpenGL book. If you want to stay up with me, you can stay up and learn with me, or else I have given the official link of OpenGL book in the description so that you can use that and you can stay with us. Okay. Uh, I better to tell you to stay up until the video end, and now, yeah, steady that. So now I changed the OBS settings that we can, and the previous videos and all that actually taken a lot of uh, files, and yeah, it taken a lot of files. So now I changed the settings. Now it is not going to take much, and I mean, so I asked ChatGPT about some AI editing app. So it recommended me which can work without. I think I can use that AI, and we can edit that our video from that. You can watch video with the editing, all the fillers and all the breaks section, and all of them will be cut by the AI. And me same time I don't want to take much more time in editing. So this one. Oh my god. Oh my god. Why it is not even open? About to piss me off. OpenGL starting our journey. OpenGL starting our journey, we should first define what OpenGL actually is. The OpenGL is mainly considered an API. An API defines application programming interface, provides us with a large set of functions that we can use to manipulate graphics and image. However, OpenGL by itself is not API but merely the specification developed and maintained by www.scaronos.org. The OpenGL specification specifies exactly what the result output of each function should be and how it should perform. It is then up to the developer implementing this specification to come up with the solution and how this function should be operated. Since the OpenGL specification does not give us an implementation detail, the actual developed version of our OpenGL are allowed to have a different implementation as long as the result comply with specification and are thus the same to the user. The people developing the actual OpenGL libraries are usually the graphics card manufacturers. Each graphics card that you buy supports specific version of OpenGL, which are the version of OpenGL developed specifically for the card series. When the OpenGL library is maintained by Apple themselves and under the Linux, there is exist combination of graphics suppliers versions and hobbyist adaptations of these libraries. This also means that whenever OpenGL is showing a weird behavior that is shouldn't, this is most likely the fault of a graphics card manufacturer or who developed and maintained the library. Since most implementations are built by graphics card manufacturers, whenever there is a bug in the implementation, this is usually solved by updating your video card drive. Those drives include the newest version of OpenGL. When using a OpenGL code file, OpenGL forces us to modern practice whenever we try to use one of OpenGL's dissipate functions. The OpenGL raise an error and stop drawing. The advantage of learning modern approach is that it's real flexible, very flexible and efficient. Okay, wait a minute. So I have to understand what's going on here. However, it is also more difficult to learn. The immediate more abstracted quite a lot from actual operations OpenGL performed, and while it was easy to learn, it was hard to grasp how the OpenGL actually operates. The modern approach requires the developer to truly understand OpenGL and graphics programming, and while it is a bit difficult. Also, the reason why this book is geared at core profile OpenGL version 3.3. Although it is more difficult, it is greatly worth the effort. As of today, higher versions of OpenGL are available to choose from at the time of writing 4.6, at which you may ask, why do I want to learn OpenGL 3.3 when OpenGL 4.6 is out? It is a good question. I will ask the same question if I were the answer to that question is relatively simple. All future versions of OpenGL starting from 3.3 add extra useful features to OpenGL without changing OpenGL's core mechanics. The newer version that all concepts and techniques remains the same over the modern OpenGL version, so it is perfectly valid to learn OpenGL 3.3 whenever you are ready or more experienced. You can easily use a specific functionality from one more recent OpenGL version. Guys, I'm really so excited to learn, and each time each time they are telling that like it is actually difficult. I don't know how much difficult it is, but I just came to have fun, and oh my god, I have no idea how it is and how hard it is. So let's see. When features of OpenGL of extension, whenever a graphics company comes with a new technology or new large optimization for rendering, this is often found in an extension implemented in their DAD. If the hardware graphics this way, the graphics developer can still use these new rendering techniques without having to wait for OpenGL to introduce the functionality in its future version. Simple by checking if the extension is supported by graphics card or phone. When the extension is popular or very useful, it is eventually become a part of future OpenGL version. The developer has to whether any of these extensions are available before using them, or use an OpenGL extension library. This allows the developer to do the things better or more efficient based on whether an extension is available. With OpenGL version 3.3, we rarely need an extension for most techniques, but wherever it is necessary, proper instructions are provided. It means the OpenGL by itself a large state missing a collection of variables that defines how OpenGL should currently operate. The state of OpenGL is commonly referred to as the OpenGL context. When using OpenGL via phone, change its state by setting some option, manipulating some buffers, and then render using the current context. Whenever we tell OpenGL that now we want to draw lines instead of a triangle, for example, we change the state of OpenGL by changing some context variable that sets how the OpenGL should draw. As soon as we change the context by telling OpenGL it should draw line, the next drawing commands will now draw line instead of. They are telling that like object in OpenGL is kind of complex, something like, yeah, object in OpenGL is a collection of options that represent a subset of OpenGL state. For an example, we could have an object that represent the settings of drawing window. One could visualize an object as a C-like structure. A GL blind object, GL window target, okay, the blind assigned object, GL window target ID, okay, then GL set object operations, GL window target, GL operation window with height control, and GL object operation, GL window target or GL option window height 600, GL blind object, GL window target 0. This is a piece of code, is a working flow you are frequently see when working with OpenGL. We first create an object and store reference to it as an ID. The original object is a data stored behind the scene. Then we bind the object using its ID to target location of a context. The location of the example window object target is defined as a window target. Next, we set the windows options, and finally we unbind the object by setting the current object ID of window target to 0. The options we set are stored in the object referred by object ID and restored as soon as we blind the object back to GL window target. The code sample provided so far are only approximation of how the OpenGL operates. Throughout the book, you will come across enough actual examples. The great thing about using these objects is that we can define more than one object in our application. Set these options, and whenever we start operations that use OpenGL state, we blind the object with our preferred settings. These are objects, for example, that act as container objects for 3D model data, a house or character, and whenever we want to draw one of them, we blind the object containing the modern data that we want to draw. We first created and set operation for these objects. Having several objects allowed us to specify many model, and whenever we want to draw a specific model, we simply blind the corresponding object before drawing without setting all their options again. Let's get started. You now learned a bit about OpenGL as a specification and a library, how OpenGL approximately operates under the hood, and a few custom tricks that OpenGL use. Don't worry if you didn't get all of it. Throughout the book, we will talk through each steps, and you will see enough examples to really get gaps of OpenGL. Additional resource nothing. The official website of OpenGL, the post of OpenGL accessible. First thing we need to do before we start creating stunning graphics to create an OpenGL context and application windows to draw it. However, those operations are specific per operating system, and OpenGL purposefully try to abstract itself from these operations. This means we have to create a window define context, and handle user input all by yourself. Luckily, there are quite few libraries out there that provide a functionality we seek, some speci- specifically aimed at OpenGL. Those libraries save us all the operating system specific work and give us a window and OpenGL context to render it. Some of more popular libraries are GLUTS, DLS, FML, and GLFW. On Learn OpenGL, we will be using GLFW. Feel free to use any of other libraries. They set out the upsell specifically target at OpenGL. GLFW gives us the bare necessities required for rendering goodies to the screen. It allows us to create OpenGL context, define window parameters, and handle user input, which is plenty enough for our purpose. The force of this, the next chapter is to get GLFW up and running, make sure it properly creating a OpenGL context and it displays simple window for us to mess around it. This chapter take a step-by-step approach in achieving, building and linking the GLFW library. We will use Microsoft Visual Studio 2019 ID as of this right. Note that process is seen on the more recent Visual Studio version. If you are not using Visual Studio or older version, don't worry. The process will be similar on most other IDEs. Building a GLFW. GLFW can be obtained from their page at www.glfw.org/download.html. GLFW already has pre-compiled binaries and header files for Visual Studio 2012. Computers say we will compile GLFW ourselves from the source code. This is to give you for processing a compiling open source library yourself. Not every library we will have precompiled binaries available. So let's download the source package. We will be building all the libraries as 64-bit binary, so make sure to get the 64-bit binaries if you are using the precompiled binary. Once you have downloaded the source package, extract it and open it, contact binaries are not available for your system. The problem with providing source code to the open world, however, is that not every use the same IDE or build system for building the application, which means the project solution file provided may be compatible with other people's setup. So the people then have to set up their own project solution with the given C/CPP and H/HPP files, which is cumbersome. Exactly for those reasons, there is a tool called CMake. But these are going facing me. CMake is a tool that can generate a project solution file of a user choice. Example, Visual Studio code blocks ellipse from the collection of a source code file using a predefined CMake script. This allows us to generate a Visual Studio 2019 project file from GLFW source project, which we can use compile their library. First, we need to download and install CMake, which can download from their download. Once the CMake is installed, you can choose to run CMake from the command line or through their GUI. Since we are not trying to overcome complicate things, we are trying to use GUI. CMake required source file folder and a destination folder for the libraries. For source file, we are going to choose the root file of downloaded GLFW source package, and for build folder we are going to create a new directory build and then select that uh, direction. Once the source and destination folder have been set, click the configure button so the CMake can read the required settings and the source code. We then have to choose the generator for the project, and since we are using a Visual Studio 2019, we still choose the Visual Studio 16 option. The Visual Studio 2019 is also known as Visual Studio 16. CMake will then display the possible of build operations to configure the resulting library. We can leave them to their default values and click configure again to store their settings. Once the settings have been set, we click generate and the resulting project will be generated in your build folder. Compile it in the build folder file name GLFWSLN can now be found and open it with the Visual Studio 2009. Since CMaker generator project file that already contain configuration settings, we only have to build the solution. CMake should have automatically configured the solution so it compiled to a 64-bit library. Now build solution. This will give us a compiled library file that can be found in a build debug name GLFW3. Once we generated the library, we need to make sure the ideal knows where to find the library and the include file for our OpenGL program. There are two common approaches doing it. We find the slash lib and include folder of IDE compiler and add the contact of GLFW's include folder to IDE slash include folder, and similarly add a glfw3 lib to the IDE's slash lib folder. This works, but it is not the recommended approach. It is hard to keep track of your libraries and include files, and a new installation of your IDE compiler result in you having to do this process all over again. Another approach and a recommended is to create a new set of directories at the location of your choice that contain all the header file libraries from third-party libraries to which you can refer from your IDE compiler. You could, for instance, create a single folder that contains a libs and include a folder which we stored all our libraries and header files respectively for OpenGL projects. Now all the third-party libraries are organized within a single location that can be served across a multiple computers. The requirement is, however, the each time we create a new project, we have to tell the IDE where to find those directories. Once the required files are stored at the location of our choice, we can start creating our first OpenGL GLFL FW project. Our first project. First, let's open Visual Studio and create a new project. Choose the C++. If multiple options are given and take the empty project, don't forget to give your projects suitable name since we were going to be doing everything in 64-bit. The project default to 32-bit. We will need to change the drop down at the top next to default debug from x86 to x64. Once that done, we now have to workspace to create our first OpenGL application linking. In order for project to use GLFW, we need to link the library with our project. This can be done by specifying we want to use GLFW3 lib in the linker setting, but our project does not know yet where to find GLFW3 lib since we store our third libraries in a different directory. We thus need to add these directories to the project first. We can tell the ID to take this directory into the car when it need to look for library and include file. Right click the project name in the Solution Explorer and then go to VC++ directories as seen in the image below. From there on out, you can add your own directories to let project know where to search. This can be done by manually inserting it into the text or clicking the appropriate location string and selecting the edit option. Do this for both the library directories and include directories. Linking. Here you can add as many extra directories as you like, and from that point on IDE we will also search those directories when searching for libraries and header files. As soon as your include folder from GLFLFW is included, you will able to find those header files for GLFW by including GLFW. The same applies for library directories. Since VS Code can find all the required files, we can finally link GLFW to the project by going to the linker tab and link to library. You have to specify the name of a library to the linker. Since the library name is glfw3.lib, we add that to the additional dependency field either manually or using edit option, and from the point on glfw will be linked when we compile. In addition to glfw, we should also add a link entry to OpenGL library, but this may differ per operating system. So these all are the steps which include how to set up the Visual Studio for the OpenGL. So I will do it by myself and I'm not going to show in the video. It will take a long time. Finally got what I want. So I actually created some file over here. Then I created some file, the main file over here. Then some C checklist text file, something like that. Then here are some sample program. So let me show you. Actually, when I click, it actually create this black screen. That is what means it created the file. So yeah, it is a default file to check whether it is work or not. So I finally created by following the book. So and it actually took me like maybe like 2 hours, almost 2 hours. Followed every step by step, and many of the step doesn't work, and then I searched all the way up, and then solved that all. So it really took a long time, 2 hours. So let's continue on reading the book. OpenGL library on Windows. If you are on Windows, OpenGL library, OpenGL 132 lib comes with the Microsoft SDK, which is installed by default when you are installed Microsoft. Since this chapter uses the VS Compiler and it's on Windows, we add OpenGL32.lib to linker settings. Note that 64-bit equivalent of the OpenGL library is called OpenGL32.lib. Just like that 32-bit equivalent, which is a bit of an OpenGL library on Linux. On Linux system, you need to link to the libgl. So the library is it I or I think IGL to your linker settings. If you can't find a library, you probably need to install any of the NVIDIA and AMD dev packages. Then once you added the both the GLFW and OpenGL libraries to the linker settings, you can include the header file for LGFW as well. For Linux user, the compiling with the GCC, the following command line option may help you compile the object minus LGLFW3 minus LGL. Okay, I don't know that. Not currently linking the corresponding libraries will generate many undefined reference errors. This includes the setup and configuration of a GLFW. We are still not quite there, since there is one other thing we still need to do, because OpenGL is only really a standard specification. It is up to driver manufacturer to implement the specification to drive that specific graphics card support. There are many different versions of OpenGL drives. The location of most of its functions is not known at compile time and need to be queried at time. It is then task of developers to retrieve the location of function he/she needs and store them in a function pointer for later use. Retrieving those locations is OS. In Windows, it looks something like this. Type diff void. Okay, buffer GenBuffer file. Okay, there are so many names that I couldn't. GenBuffer, GL get address. As you can see, the code looks complex and it is cumbersome process to do this for each function you need that is not yet declared. Thankfully, there are libraries for this purpose as well, where the GLAD is popular and up-to-date library. Setting up GLAD. GLAD is an open source library that man all the work we talk about. GLAD has slightly different configuration setup than the most common open source libraries. GLAD uses a web service where we can tell GLAD for which version of OpenGL we would like to define and load all relevant OpenGL functions according to that version. Go to GLAD web service. Make sure the language is set to C++, and in the app section, select the OpenGL version of please is what we will be using here as well. Also make sure the profile is set to code and that generate a loader option is triggered. Ignore the extension for now and click generate to produce the resulting library files. Glad by now should have provided you zip file containing two include folders and a single glad C file. Copy both include folder glad and KHR into your include S directory or add an extra item pointing to this folder and add glad.c file to your project. After the previous steps, you should be able to add files into directory. Hitting the compiler button shouldn't give you any error. At this point, we are going to set to go for the next chapter where we will discuss how we can actually use GLFW and GLAD to configure an OpenGL context and spawn a window. Be sure to check that all your include and library directories are correct and that library names in a link settings match the corresponding libraries. So these are all the links they have given. Hello window. Let's see if we can get a GLFW up and running. First, create a .cpp file and add the following include to, to the top of our newly created file. Be sure to include GLAD before GLFW. The include file for GLAD includes the required OpenGL header began satiate the GLFW window. In the main function, we first initialize GLFW with the GLF win, after which we can configure GLFW using Windows hint. First argument of a Windows hint tells us what option we want to configure, where we can select option from a large enum of possible option prefixed with the GLFW. The second argument is an integer that sets the value of our option. A list of all the possible options and its corresponding values can be found at GLWFW, the Windows documentation. If you try to run the application now and it gives a lot of undefined reference errors, it means you didn't successfully link the GLFW library. Since you focus on this book is OpenGL version 3.3, we would like to tell GLFW that 3.3 is the OpenGL version we want to use. This way GLFW can be make the proper arguments when creating the OpenGL context. This ensures that when your user doesn't have a proper OpenGL version files to run, we set the major and the minor version both to 3. We also tells GLFW we want to explicitly use the core profile, telling the GLFW we want to use the core profile means we will get access to a smaller subset of our OpenGL features without backward compatible features we no longer need. Note that on Mac OS X you need to add a Windows hint, OpenGL forward, compact GL through to your initialization code for it to work. Make sure you have a OpenGL version 3.3 or higher installed on your system hardware. Otherwise, the application will cursor display undefined behavior to find the OpenGL version on your machine, either called to create a Windows object. This window object holds all the window data and is defined by the most GLW FWS other functions. Okay, here's the program. Then okay, window equal to anything it is a width and height. They called inside one function. The GFW create a window function required window width and height as a first argument. Respectively, it will allow us to create a name of a window. Okay, for now we call it learn OpenGL, but you are allowed to name however you like. We can ignore the last two parameters. None. Okay, the function return this glfw window object that we will later need for other GL operation. GL operation after that we tell GL. I will call this GLFW instead of GL. Okay, for this also to make the context of our window the main context of on the current thread. In the previous chapter, we mentioned that glad manages function pointer for OpenGL. So we want to initialize a glad before we call any OpenGL function. Okay. So not equal to glad glad load and then GL get versus matrix. Okay. Okay. So we passes. So here we are creating some windows, right? Yeah. Then here we passes a glad function to load address of OpenGL function pointer. Where's the pointer? Okay, function pointer which is OI specified declared address that define the current function based on which OS we are. So the GL get probe address it is the pointer. Okay, so this one is actually we go again learning a C++ from scratch. Day 14. Today we are going to read ready your engines. Make sure to follow my Instagram and make sure to join in my Discord and make sure to subscribe my channel and let's continue our section. We don't want the application to draw a single image and then suddenly quit and close the window. We want the application to keep drawing image and handling user input until the program has been explicitly told to stop. For this reason, we have to create a while loop that we now call the render loop that keeps on running until we tell glfgl to stop. The following code shows a very simple render loop. Okay, the while loop and then GL window should close. Okay, then GL snap before, then GL poll events. Okay, there are some functions called inside the while. So if it is not, if it is windows close, then this loop will run by itself. Okay, so The GL windows should close function check at the start of each loop iteration if a GL has been instructed to close. If so, the function remains true and the render loop stop running after which we closed application. The GL poll events functions check if any events are triggered like a keyboard input or mouse movement event update. The Windows status calls the corresponding function which we register callback method. The GL snap buffer with the snap color buffer, a large 2D buffer that contains a color value for each pixels in a GL windows that used to render to reduce this rendering iteration, and so it's as a input output to the screen. So guys, so now I understand a little bit, not everything. So we have a AI nowadays, so we can use an AI to understand better more. Okay, use an AI in a learning process for don't use AI for everything. That's what I say. And some of the people's some of the people said me to don't use AI for learning something like that, but I don't know what they actually trying to say something like that, but they just simply said like that. But I don't know why they said, but we can use the AI to understand the more uh, I mean more clearly and uh, more accurately and easy to understand everything. You know, it is AI to study business and advanced user also. So they mean the render loop keeps okay, I got what they mean here. Now the render loop simple version while GL windows should be close not equal to. Here uh, they're using a not equal because so according to this condition the while is a loop and then we are using a while loop then a not GL window should be closed. If it is not, then inside of the loop will keep run by itself. And when the user press the uh, click the close button, it will close, right? I think. Wait a minute. Yeah, it is okay. I just got confused a little bit. Just so I'm thinking so hard. Okay, yeah, it is. Okay, so keep looping while the windows is not closed. Yeah, once the user close the window, condition become false, loop stop and program ends clearly. Yeah. So the GL's buffer window. This is how the image appears on the screen. Okay. You open GL draws everything to hide a buffer but back button. What? OpenGL draws everything into a hidden buffer. Mm, I don't know what it mean by hidden buffer. To be honest, I don't even know about the inner buffer and outer buffer, something like that, front and back, whatever. Okay, let's start chatting. Right back. No above. Uh, to be honest, I don't even know. To be honest, I'm not gonna lie. Just I'm here for learning. The first, what even is buffer? Okay, the buffer is just a memory RAM that store data temporarily. Okay, that's a simple line, guys. That's a simple line. Buffer is a memory. Yeah, actually, it is a RAM and that stores data temporarily. Okay, that is what it is. So simply, the buffer is a RAM. Okay, that's it. Buffer is a RAM. Okay, no, not scary, not advanced, just storage. Okay, just storage, just a RAM, man, like a RAM. Okay. Now, in a graphics term, when the OpenGL draws something, it do not draw directly on your screen. When a OpenGL draws something, it does not draw directly on your screen. Okay, why? Because drawing pixel by pixel directly would look like a glitchy garbage. Okay, so instead OpenGL draws into a buffer. Okay, so the OpenGL first it runs on the buffer, then the buffer it runs on the buffer shows the data as a displayed object in Windows. I mean screen, right? I think they are mean like that. I'm not sure what they mean. It's like this a real life analogy. Imagine you are drawing a picture drawing directly on a billboard in front of people. Okay, everyone sees the half drawn lines raising is okay. Drawing on a paper backstage. When finished, you flip it and show it. Guys, seriously, I have no idea what's going on. So in here, drawing it directly on a billboard in front of people. Okay, it is simple. Okay, so everyone sees the half-drawn lines and erasing means I don't understand this line. So okay, and drawing on a paper backstage. What do you mean by backstage? You mean didn't show something? Didn't show the what you draw to the people, something like that. I think it mean like that. When finished, you flip it and show it. Yeah, I think it is something like that. Okay. I don't know what actually is going on. This call complete got it. The line you are asking about, yeah, what this means, the best step. Imagine a huge billboard on a road. Okay, you are the artist. People are watching live. Got it. What happens if you draw directly on it? Oh, what? So you draw one line. The people see that line. You erase mistakes. People see the erase. You draw off circle. The people see the broken shape. You fix it slowly. The people see all the ugly parts types. Unfinished saves, flickering changes, messy update. That is exactly what happened in a graphics if the computer draw directly to the screen. Okay, now relate this to OpenGL. If OpenGL drew directly to screen, the one triangle appeared, then off other triangle, and then color changes, then the picture updates slowly. Your eyes would be see flickering, tearing, ugly frames, not smooth, not clean. So what's the solution? Don't draw in front of people. Instead, draw behind the screen. Finish everything, then show all at once. This behind the screen place is the back buffer. The final mental piece lock this in. Piece screen, screen front buffer what people see. Back buffer bad drawing happens secretly. Okay, the GL's snap before windows. Okay, so the final picture. So this program is actually printing the uh, final complete art, or yeah, something like that. Okay, so the one line takes away. Drawing directly on a screen is messy. So OpenGL draws secretly in a buffer and then show it only when ready. Okay. If you want, I can explain again using a game, shooting and trying on real man. Okay. For now, I'm good. So let's back to two important buffers. This is a key. A back buffer, hidden buffer. Yeah, the OpenGL draws here, and user cannot see this. This is where all the drawing happens safely. Okay, it is already explained. Front buffer screen. This is what you actually see on screen, like this. Okay, graphics. This is a back buffer. The primary surface draw. Okay, the image back buffer, and then it's okay gives something like that. Before calling it snap buffers, mouse screen buffer. Okay, and on screen buffer. Oh, but it is looks like some pentagon, maybe something like that. So, but it is look like a pyramid, something like that. After the first call to snap before watch. Okay, after second call to snap watch. So okay, so for this diagram I don't understand what they mean, to be honest. So, okay, so what does GL snap buffer window do? It really swap them back buffer become visible, front buffer goes back to be reused. Oh, let me think. Yes, now I understand. So it is this on-screen buffer. It is already in here, but in begin buffer, it was actually programmed and it is actually working on here. So when we call this function, it actually print this instead of this because we are calling this here. So yeah, so now here after the calling this pentagon, the user didn't give any program data, something like that. So it is still remains empty. Okay, so when the user runs again, this image gone because the buffer is empty, because we didn't give any data, something like that. So on the next call, it actually prints nothing because the buffer is empty here. So it is still empty here because of that we get an empty screen, I mean empty buffer, front buffer. Okay, oh my god, it is actually close to all of that. Lord have mercy. So that is it. So yeah, we already did this. Now buffer memory, buffer hidden area, and screen and the swap buffer. So what you do? Yes, it is. So we don't have a confusion way. Okay. So now let's move on here. Okay. We actually got what actually doing the snap buffer. Now focus on this GL poll event. Okay, I don't know what exactly. Okay, this is how. Okay, check my mic is okay or not. Okay, so this is how your programs listen to the user. Check for keyboard presses, mouse movement, mouse clicks, Windows resize, close button click, and then update GL internal state, call any callbacks function you register. Without this line, the keyboard won't work, mouse won't work, Windows may freeze. Okay, guys, give me some second to understand what's going on. So yeah, I got it. What they mean. Okay, now why all this needed without render loop? Windows open, one frame draw, programs exist immediately. Windows close instantly. Yeah, I have experience on that. So I got what they mean. Okay. With the render low, Windows stays open, frames keep updating, user can interact, program closes only when told. Mm, So this is what they mean by render loop. Okay, there is no confusion, but the render loop, the word render loop, it is a new word to me, so it take a time to be remembered all the time in my mind. So, okay. Where is the code? Okay, the mental model remember this. The while window is open, frame draw, so draw, listen to user. That is it. Okay, what's going on here? But it looks like some kind of um, what was that? I don't remember that. There was something called pseudocode. Pseudocode. Yeah, pseudocode. Okay, pseudocode. Is it not even pseudocode? I think while Windows open, while Windows open. So wait a minute. So this function, where is it? So it is a swap, right? It's a swap. First one is a okay. First one is a window should close. Okay, now I am. So first one is a window GL window. Oh no, GL should be closed or something like that. Yeah, GL window should be closed. Right, that was the name. I have a doubt that the function name who comes here, right? The GLFW window should be closed. I think those are like a predefined something like that because I think like that, but it might be customized name something like that. But let's see. We are going to see about that, so there will be no confusion. So let's move on reading. Double buffer. When application draw in a single buffer, the resulting image may display flickering issues. This because resulting image is not drawn in an instant, but the drawn pixel by pixel and usually from left to right and top to bottom because this image is not displayed at instant to the user while still being rendered to the result may contain artifacts to circumvent these issues. Windowing application apply a double buffer for rendering. The front buffer contains the final output image that is shown at the screen, while all the rendering commands draw at back buffer. As soon as all the rendering commands are finished, we swap the back buffer to front buffer so the image can be displayed without still being rendered to remove all the aforementioned artifacts. So guys, so yeah, you guys may guess what I mean. Uh, I yeah, just remove the AI to for the better understanding. All that we have a master for coding, so we can learn. The people still really some of people I don't mean all the people, but even for example, even Elon Musk said using AI to learn anything. Even he recommended to use an AI because he said by himself he knows what AI capable of, you know. So don't think AI as a bad stuff. We can learn from that. It have a lot of thing. The lot of people have asked to work on the AI to train the AI, and the lot of peoples and lot of knowledge are actually involved and give the data into it. So it is better, and it is a open source. It is not a paid one or something like that. I'm still using a free version, something like that. So don't think AI is a bad. To be honest, it is bad, man. Seriously, don't. We can learn. It can teach easily as people as we want. So don't think, man. It can teach you anything, man. If you don't understand, just watch some YouTube and use some AI for the better understanding. That's it. Learning a thing manually will take a long time, you know. If you really wants to give a lot of time, you can do it. I'm not going to stop you or anything like that. But using AI won't take a lot of time and you can learn easily. That is the main goal, you know. So technologies are actually growing rapidly. So just use them. That's it, man. I really hate some people who actually telling me to stop using AI, don't use something like that. They just read a book. Oh my god. I mean, we are using that for understanding, man. But nobody understand. Sorry, I mean somebody don't understand. Okay. Uh, why the freaking happens using a buffer? For program. Okay. Okay, it is almost on. Okay, so I had some work. So today I can't learn much because I went to the college. So that is why. So I will learn stuff for long from tomorrow. Yeah, just I just don't want to quit the series. So I just learning today. The image is drawn pixel by pixel, left to right, top to bottom. It takes a tiny bit of time. Why this happen? the user already see the image. So the user sees a half drawn image, lines appears one by one, random visual glitches called artifacts. This is what we call flickering. So what is flickering? I don't know, man. Mm, so some kind of a light flickering, something like that. Oh yeah, I think so. So why drawing is slow? Important detail. Drawing is not instant. Even though it feels fast, the GPU is actually doing the text drawn pixel, draw pixel, draw pixel. It is going infinitely, no one can stop. So, okay, so if the screen shows the image while it is still being drawn, it looks bad. What do you mean? If the screen shows the image while it is still being drawn, it looks bad. Okay, yeah. Sorry, my fault. My fault. I didn't get by one time. Okay. So what is going on here? Looks like graphics backfront. Sorry, back buffer. Image surface, video pointer, screen. What's going on here, guys? Can anybody? Okay, page screen. Okay, block flip. Okay, it is going. Then primary surface. What? So it okay swap like that. Okay, it is swap. Then primary surface has the this image. Then back buffer come this way, and the screen actually has a some image from here primary surface. Okay, so raw graphics image back buffer primary survey image back buffer primary surveys. Okay, I got a little bit. Yes, from the image I understand. Okay, the friend before this is what. Okay, why it is actually telling the same thing? Maybe they have contained the same thing, something like that. Okay, do I reading the same thing? No, I did not. Drawing everything in a back before hidden. Showing a drawing the whole image swap buffer. User sees the final image instantly. This that is a line. Okay, we already seen this. Okay, is getting the user never sees a drawing process. They only see the complete image, not half drawn pixel, no artifacts. Artifacts. Okay, okay. The artifacts has good sound. Okay, so the drawing directly to the screen causes flickering. So the programs drew secretly in a back buffer and so it only after the frame. So ready for something. Okay. Yeah, we already know that. So okay. So guys, I had some work, so I couldn't able to study long today. Just 1 hour, and I actually found some AI for the editing, and it actually reduced the whole video into a small one. Guys, sorry, I went some. So yeah, so let's continue the section tomorrow. Okay, like I mean day 15, right? Yeah, day 15. So and I actually used some AI. So I forgot to mention that. So I used some AI for the editing. Our previous videos I just upload all the files without editing or anything, just upload everything like 4 hours 3 hours. Then I realized that it is actually not good, and you guys don't watch. So Now I'm going to edit all that and going to mention the only thing I talk. I'm going to remove all the space and breaks, everything, and going to merge everything, and the video will be too small, I'm sure. So yeah, I'm only mentioning the thing I talk. Okay, so the breaks, space, everything will be gone from the day 13. Okay, the day 12 I upload the whole thing, but in a day 13, from the day 13 I will cut all that into small video, and make sure to you guys to watch our whole video. Okay, it won't be big, maybe 20 minutes or 15 minutes, something like that. Okay, so it will be too small, not too big. Okay, so I appreciate you guys to watch whole the video, and it really helps me. So there is a link in description for the donation. If you guys willing to donate me, you can donate whatever money you want, might be a 50 cents or 100 cents. So yeah, I mean, maybe $1, $2, $5, $10, $100, whatever, and might be 100 rupees, 50 rupees, 20 rupees, 10 rupees, maybe 1,000, something like that. You can donate the whatever you want, and if you really need to help me, you can help me. And I just want to get a new monitor, so you can help me with that. Okay, so I can use a small 21-inch laptop monitor for everything. So it will really help me if I really get that. Okay, so yeah, so see you tomorrow. Bye.